right, hello everyone. Let's get this show underway. Rholang, are you ready with the tech update?
Yes, I am. There's the link to Community Update 223. I'm going to share my screen. All right. So basically, the team is continuing to make good progress on the finalization piece to complete or get ready for the hard fork 2 release. And Tomislav has issued a draft PR on refactoring the block metadata. And I think he's expecting to complete this tomorrow. And then it has to go through the review by the team. And he's got a few more pieces to work on in the finalization. And then once he's done with that, NutZipper will be doing the block merge portion of the code in parallel. And Tomislav, as he is working through the finalization, he identified that there are a couple more parts of the code that need to be refactored. So that's what he's going to be working on over the next few days. So that's where we are with the core finalization piece. And NutZipper has completed refactoring the deploy storage and the API changes necessary to get the enhanced deploy information. He's got one more PR, I think, that he needs to do there. He's put in between, there is a refactoring PR that he also had to do. But he's got one more PR to complete that whole activity. But separately, he's also been working on generating Rholang deploys from RabbitMQ in Scala for integration with external systems. This is for a particular customer that we're working with where this is needed. And this exercise was very helpful in that it kind of gave the team insights on how to improve that kind of an integration for future. I don't know what's going on with Jim White's cover. It keeps saying admit 20 times, but hopefully he's in and he's able to watch. And Will had been working on the registry updates as a soft fork activity. So he has completed the work there. He's implementing now the review comments from others on the PR. And one of the next things he will be basically writing up as a task is to change the calculation for random seed because we are getting rid of timestamp and things like that now. So he will be redoing that piece, and Max and he will be implementing that. Will be implementing the core part of that. Max will be implementing the portions of that relate to scodec because Max is already familiar with that. Other than that, Max has been working on improvements and tests for Radix, the new Radix history implementation. He's been working with Dennis on that. So, and Stas has been working on this block receiver state, implementing the block receiver state. So that's a substantial chunk of work. So he's been implementing review comments and making additional PRs necessary for that. And then he also has to write tests for that. He may have to create something like a CLI interface to be able to test that. Dennis had been spending time, like I said, on improving Rholang map set and other things. Primarily, he had been investigating what are the reasons for that. He now has a good idea of where things are with that as to what needs to be done to improve the performance of the Rholang primitives. However, in terms of doing the full scope of improvements, there really requires extensions and modifications to the Rholang reducer, as well as implementing more of Rholang 1.1, which is a substantial task, and this is scheduled for second half, basically. So that even though there is a small portion that he can implement there for improving the performance of the map, in the balance of things, it doesn't seem like it's worthwhile to do it now because that would be almost not noticeable without doing all these other changes. So since the other changes are really scheduled for second half and will not be able to be completed within the hard fork 2, what he's going to do is he's going to document his work to date, the insights gained and the performance measurements and all of that. And then he'll return to that task later in terms of improving the Rholang primitives performance. What he's going to be doing now is switching to implementing the BigInt type in Rholang, which I know Jim and others have been asking for. And that's also a reasonable sized task, but it's something that we expect that it can be completed within the hard fork 2 time frame. So he's going to be switching to that, and probably he'll be sharing some portion of that with Max in terms of who is actually going to do that work, but he's going to get started on that. The issue around BigInt is described in this RChip proposals. That's a separate repository from the main repository. So folks that are interested in that can take a look at it. And some of you may remember that when we are going for large token, such as in case of RPC and Dazzle, the BigInt was one of the issues that we had to deal with and have some workarounds. But it's much broader than that in terms of, so this is a feature that the developers will notice as being beneficial once we're done with it. So that's why we're focusing on that, to get that out. So in general, there's substantial market engagement going on with enterprise customers and systems integrators that want to deploy on the chain. So that activity is going on, and I think some of those details are discussed in the closed doors meetings. So that overall is the tech update. With that, any questions, comments from anyone? Over to you, Greg.
Thank you, Rel. Yeah, I'm excited. We're starting to see the not just the block merge come together, but we're seeing the capabilities to actually use the system in a wider range of applications, and that's very important. So
one quick question.
Sure, go ahead.
The block time is removed from the block? Yes. Did I misunderstand that?
Yeah, we're taking the timestamp out. Yeah.
I think, well, I guess I did put my arguments in for that. Why I think that's a mistake. But
yeah, I think it's a lot of people are arguing one way or the other. So my perspective is that it's okay to put it in as long as people understand that the only validation we can do is to check that the time is later than any of the justifications. What that then does is that opens us up to an attack, right? So if a validator accepts a time that is later than all the justifications, but also, max in terms of time, and that validator can never accept another block, right? Because there will never ever be another block that has a time that is later than that one.
Yeah, well, my suggestion was to simply ignore the block time, except that over the long term, there is an indication of time by consensus across multiple blocks.
Well, what you can get is you can get a map from block height to time, and so that's what people can do.
And if they're not in order, well, you obviously you don't want to consider that to be a sequence. If they're in order, that's evidence that they're. It's simply a data point that's not trustworthy alone, but can be trusted in the long term, in terms of what the median or whatever it is. Just throw out the bad points.
Yeah. So anyway, it is possible to get a map from block height to time that is, has roughly the same accuracy as what you would use a timestamp for.
Yeah, I mean,
yeah.
Jim, I think basically what you're saying is keep time stamp as a non-validated, non-relied upon.
Right. I can write a contract to estimate the time based on history of block times, throwing out the bad points.
Yeah, but you can also write a contract that goes from block height to time, and that will have the same.
We need approximate time. Whether it's once a day, or once an hour, or once a minute. We should have some notion of approximate time, and we can get that by looking at the history of block times.
You can get approximate time.
You can extrapolate. You can get an approximate. Its accuracy doesn't have to be that accurate. I mean, if I have a contract to do something for Tuesday, I don't want to have to consult an oracle to find out when it's Tuesday. I mean, I think there's a better solution.
Yeah, the solution is block height. You can go from block height to time.
So you create
over a period of time, you can see what the average block time is, and then you can.
But if you don't have block time, how can you see that? I don't get it.
No. The time to produce blocks, right? So that's an external data point. So you can look at external data point. You can say the time to produce blocks is roughly X, and so then you can go from block height to block to time.
Yeah, except that doesn't help me at all when I have a contract that lasts a year.
Well, that's what Raphael is going to be doing, and he has expiry dates on his stuff.
Jim, what I'm going to do, I'm going to paste here for you. I don't know if you reviewed this issue yet, but comment on this issue. I think that's 3691. At least it's one of the issues that's dealing with timestamp. I think there's one more, but I can get those to you. So review that and comment in there whatever your suggestions are, and then the devs can take a look at it. But in general,
we shouldn't be taking the time here. I'm just saying that it doesn't hurt to keep it.
Yeah, I mean, the key is that it cannot be relied upon for anything because there's no consistency around it, and it's manipulatable. Especially if somebody gives like a long future time, that kind of a thing. So it's take a look at the issues as to what those are over there, and then comment in there. I think the team will take a look at that.
Yeah, that's just a stupid use of it. If they abuse it, it's not going to make any. It's just going to be ignored. There's no reason, you don't have to use it stupidly. All right, go on. I'm sorry.
No worries. The problem is if you ignore it, then people can put all kinds of data in it. So you can't ignore it. You have to validate it. And then the question is, what is the validation criteria?
Yeah. I mean, basically, we should not call it timestamp in the sense that timestamp has some legitimacy to it. So we have to call it something else like reported time or validator time or whatever it is. that has nothing to do with any legitimacy to it, so that people are not relying upon it, right? I mean, that's basically what we need to do. And basically it becomes a data point that's not verified, that's not relied upon. Like right now, we're using it as part of the random seed generation. That's one of the things that they're dealing. They're trying to get rid of that dependency. So yeah, so go in the issue and comment on it as to what you think might work relative to the goals that the PRs are trying to accomplish. So
Yeah.
Awesome. That's a good discussion. I appreciate the concerns. They are legitimate concerns, and
yeah, I guess I see the problem, that I don't see the solution. Oh well.
Yeah, well, again, Raphael is the only client we have that actually is offering a service that is related to time. So DAPI offers these leases on names that come up in a year, and he's happy to go from block height to time.
Yeah, we certainly need it for RGov also.
Sure.
Yeah, I mean, I think in truth, there will be a lot of applications that would want something like a timestamp, but the fact of the matter is that the timestamp is not reliable in this situation. So rather than giving it a name that gives it some authenticity and confuses people, we have to declare it to be what it is, that it's some reported time, it's some reported random number, basically. And what people want to make of
it's not just a random number, it's monotonically increasing, right? And then that's where things start to get. Go ahead.
Yeah. I mean, Greg, I was just going to jump in here real quick and just say that I think most uses of time and timestamp that Jim and everybody is talking about, and that I've been jumping into, almost all of it has to do with expiration, as opposed to authoritative time. So
yeah, but expiration can be done in terms of block height. So
yeah, it can be done in other ways. It's just you like you were saying, Greg. It just needs to be guaranteed that it increases with some kind of predictability over time, right? Yeah.
I mean, the issue is that you can't get an upper bound on it, and that's the problem, right? If someone picks too large an upper bound.
Yeah, no, I understand. I understand that problem. I really do. It's a security vulnerability. I get that. But,
yeah.
But what I mean, even in RPC, we're talking about leasing out NFTs for a certain amount of time to a museum. So
yeah,
it's all about expiration. It's not necessarily about absolute time. So.
Yeah. So for expiration, if it's just expiration, you can use block height, and you're just fine.
How do you know what the block time is going to be?
It's not the block time, it's the block height.
Yeah, right. How do you know what the block height, in order to associate block height with time, you have to know the time, right?
No, you don't have to know the time.
Basically, you need to have a self-adjusting algorithm that takes, okay, today, what block height am I at? And then based on that, you could calculate whatever blocks per day or something like that on an ongoing basis. And somehow
we don't know how many blocks we're going to be able to do in a day, or we're going to do in a day.
No, you don't look forward. You look back. What you say is, what was the block height yesterday? What's the block height now? And now in the 24-hour period, how many blocks are produced. Now you've got an average block time. And so now you can go from block time to, from average block time to wall clock time with the block height.
Just a quick question, and I don't want to get into the weeds or belabor this anymore, but this metric of block height in relation to time, wall clock time, that's utterly dependent on the amount of physical threads and hardware available to shard. Is that correct?
That's exactly right. Yes, it's absolute. It's relativistic, right? In the sense that yep, and that's the best you can ever do. Can't ever do better. From a physics point of view, that's the best you're going to be able to do. Right? You'll have the same. Go ahead.
Sorry, what happens if the network is down? Like, how do you calculate like approximate time if network was down for like 2 hours or something?
Again, this is the same is going to be true. If the network is down, you're going to have the same issues with block with timestamp. And if you have a node running on a Mars probe and a node running locally, you will have relativistic drift. If you have a node running in a satellite and a node running on the ground, you'll have a relativistic drift, and so on and so forth. You never get global wall clock time. It doesn't exist, right? And this is, our best, most verified scientific theory tells us that this is the case. So we can't expect, accurate wall clock time in anything but very, very constrained circumstances, and certainly not in a decentralized or distributed setting.
Yeah, so, I think relying upon timestamp in a decentralized setting, then you're basically relying upon network latency and all those things to become parts of the equation is part of the reason why we don't want to rely upon timestamp in any way. But I think the argument being made is like, can you just leave something in there that we could do something with later? And that
but the point is, if you want something that's vaguely accurate, then you go to the observer nodes, and you on a regular basis you sample how many blocks have been produced over a period of time, right? So you're
using an external clock.
You're using an external oracle, right? Which is the best you can do. Use an external oracle. You go and you say, what's the average block time over this period of time? And then you say, okay, on the basis, then you say to your sources who are relying on you to calculate time, you say, this is the source I used for my time calculation. This is the average. Time to produce a block, and this is the delta in the block height, and so the time is blah. And that's the best you can do. Anything else is good. Any other mechanism is going to be about as accurate as that is.
Yeah, well, I think it's the nature of time that it is relative, and as long as we understand that, I think we can determine an approximate local time for.
Yeah, right, but it's not recorded in the chain
perspective.
Yeah, and an approximate local time should be calculated locally, not in the shard, right? So whoever needs a local time, they use their local references to calculate the time.
Yeah, well,
and that can include an observer node. So you say, my local reference is this observer node, and this is the algorithm, this is the contract I use to calculate the time. And and you're done. You don't have to worry about it, right? You can write that contract once and run it forever.
I will put in, my argument of just keeping it, because I think it does have value. Although, if validation could be a problem, I don't really understand. When somebody submits a block, it has a block time. They don't need consensus. They only need consensus on the time that was reported. They don't have to.
No. That turns out to not work, right? Because the one thing you need to check is that the time is after the time of reported by all the justifications. And now you need to say, and what's the delta? What's the legal delta? and that's no longer that becomes a problem. If you don't check anything, right, then people can put, you know, all kinds of things. They could put child pornography, right, in the timestamp. So you have to check something. And now once you start checking something, what is it you check?
Well, you can check that as a timestamp. You don't have to accept child pornography.
Okay, all right, yeah. So it's just a random piece of data that people are putting in.
A random timestamp.
So, well, we don't even know that it's a timestamp, right? Unless you're gonna to say what the format for timestamps are.
Well, when we use the standards.
If you really want to take this up with Tomislav. I argued to Tomislav that the only thing he wants to check is you know, that it's later than the justification timestamps. But he felt that that was insufficient as
yeah, that's a problem. It becomes problematical if you reject it. You know, the thing is, you don't have to believe it, and you don't have to reject it.
Yeah. Again,
we can take it up in tech governance. Yeah, I think there are
take it up in tech governance.
There are security issues that Tomislav was worried about. That basically, if we leave it in there and are not validating it, then it becomes problematic also. So
yeah, and it's not just technical issues, right? It becomes a liability. You know, if someone comes along and they write some code relying on that data as representing something, then we could find ourselves in an expensive lawsuit where, you know, it's not even whether we're right or wrong. It's just that it just wears down resources because of the lawsuit, right? It wears down people's time and energy and takes you know, we spend a bunch of money on a lawsuit. And so you have to consider all of these different
of these different forms of attack. You don't want to end up in court arguing whether or not the sky is blue.
Yeah, exactly. Absolutely. So
but you know, you can't be sued by a time that somebody else reported. You know, I don't know.
Especially if you rename it to something like approximate timestamp, like no one will possibly rely upon it if it says approximate.
Maybe use at your own risk timestamp.
Yeah. All right. Well, we can take this up in tech governance.
All right.
Okay. Sure. Thank you. Good discussion. Daryl, do you want to give the week in review?
Sure. Hey, everybody. So here's the week in review from last Thursday, May 5th to today, May 11th. On Friday in the Climate and Coordination RCast, Jim Whitescarver and Tom Moulton joined us. We discussed air pollution in the UK and beyond, and venture capitalist John Doerr's billion-dollar gift to Stanford to establish a new climate and sustainability school. We also discussed Jim's history and his pioneering days in collective intelligence research and the early days of chat and more. And I think Jim's going to join us again for Jim Part 2 of the RCast on Friday. On Monday, in the Casper Stand-Up, this week's Casper Stand-Up covered refinements of the interpretation of QM into row calculus. We also reviewed metered computation in row and how to modify it to do debugging and reversible computation. Yesterday in the Communications Working Group, we discussed developing an RChain's near linear scaling proof and explainer video and how to present our various investment opportunities. And this morning in the Active Member Hangout, I asked Jim to explain more about his initiatives with RGov and RDev, which led us to encouraging Jim to write a book. Michael was on the call from back in the scenario days, and he explained his ecological research using plant ecology to explain a full biometrics, determinative analysis, indicator research, kinds of measurements. Jim talked about RDev as a scientific experiment. The intention is to continue the research at NJIT to develop collective intelligence. And that brings us to now.
Awesome. Any other questions for Daryl about the week in review? Okay, so the board.
I guess I should mention I was lax and I didn't report on the smart contract Saturday, Dan's office hour, which the first part of it is on using Zoe to put contracts on Agoric, but then we went into capability transport and comparison between Rholang and Agoric code and how they can transfer back and forth one another easily, but they need things like big int and float in order for us to move objects across the barrier, or to marshal them across the barrier.
Yeah, I'd like to see how they easily transport a large parallel composition.
It's very mechanical. Dan already has a converter partially done, which supports main parts of the language.
That's what I'm saying. The thing where it's interesting is parallel composition, because to the best of my knowledge, they don't have a means to do that consensus,
yeah,
right?
That's true. Yeah, that's true. Okay, what they do well is the object capabilities, or the capabilities. So we're not really talking about objects, but the capability transport and the inter-blockchain communication. But they have a wealth of code that can be converted to Rholang that does everything. I mean, does so much that we want that it makes sense for us to, take their code for exchanges and just use that code, on RChain. In Rholang.
Totally going from their language to Rholang is not a problem, except for the data type. Yeah, I agree. What I was thinking about was going the other way, going from Rholang to their language. I think is remarkably difficult, because Rholang offers concurrency and they don't have a target for that, so they'd have to come up with a kludge.
And the second half of that video is very good, and I highly recommend it. I'm not sure that it's been announced outside the collab, but it's in the Divi YouTube channel.
I will say this, Dan is very excited to work on the marshaling of concurrent Rholang into the Agoric space. He's very excited to do that.
You mean marshaling the Agoric stuff over into concurrent Rholang?
No, the other way around, I think.
I don't see how he does it.
Yeah, I understand your perspective, but he's very excited to hop on it. Him and I are brainstorming.
Okay. Let me know when you got something. I'll.
It's a tough nut. I agree.
Yeah, no,
it actually isn't, right? The simplest thing to do is to use a model of concurrent computation. Then it's very straightforward. It's just that they don't have one.
Dan is very,
okay.
Well, that's why we want to be able to deploy on Rholang from Agoric, because Rholang provides that.
Yeah, exactly. Yeah, that's kind of the whole point. That is like the real essence of the thing. There's like, and to be super clear, right? it doesn't matter what consensus algorithm you use. Like we could use PBFT for RChain, or we could use, you know, some other completely straightforward consensus mechanism rather than something, you know, that was, you know, you know, that came to Vlad and Vitalik and I tried to make sense of, right? That we don't have to rely on an experimental consensus model. We could use any consensus whatsoever because the scaling doesn't come from the consensus. The scaling comes from the fact that you can, you know, take physical threads and turn them into performance. And so if you don't have a model that allows you to get consensus across the threads and to do merging, right, where you can auto detect, does this thread touch that thread, then you have a real problem. You won't be able to scale. So there's no technical argument for why you would go from Rholang to Agoric. There's a lot of technical argument for why you would go from Agoric to Rholang.
Well, the only technical argument I could make is that they have stuff working. So if we want to exchange Rev for ETH, we can do that easily on Agoric through Galaxy on Cosmos. And we can synchronize with other, you know, they have 1,000 other nodes on the network that we can use what they have working while we're converting it to Rholang. That's the advantage.
We have stuff working too. I mean, yes. I guess I'm confused, right? I don't know. Do they have people using the stuff they have working?
Absolutely. Well, in beta.
Yeah. Right. So
no, they're
we
not
don't have
ready
people
either,
using our.
But
yeah, we don't have stuff. We don't have people using stuff in beta. We actually have lots of transaction dollars flowing through the network on a regular basis.
Right, and you know, they have a development path also, but they are going live any day, really. They're ready.
Okay. That's good to know. That's good.
And they already have. Well, they have a mainnet. I don't know how to answer that. They have a mainnet.
It's not about mainnet. The question is,
it's not fully functional yet, the mainnet, but it does have thousands of nodes.
Awesome. All right. Anything else? Any questions, comments, concerns, considerations from the community? All right. Thanks, everyone. Appreciate all your time. Good discussion today. And we will see you on the other side.